Hello friends, welcome back. In this tutorial, we are going to learn about Kotlin Flows. So let's consider we have to get some data from the server and we make a call to the server and server provides us with the data. So that is a one-time operation. But let's say we want to continuously keep receiving the data. Server is continuously sending the data and we want to continuously listen to the data and we want to continuously use that data, show that data to the user, just like a live streaming application, like just like you are watching this video right now. You are watching it on YouTube and you are your device is just continuously making a request to get the data and server is continuously providing the small snippets of the data. So this is something that the flows can achieve. So that is the basic need of flows. So flows make that concept very easy and we can use flows to implement such a concept in our own Android application. So this will be a tutorial series containing different types of flows like a state flow, shared flow, and we'll also going to talk about what is hot flow, cold flow. So this is the first video of this tutorial series. We'll be seeing a normal flows in this tutorial. So let's get started. So here I am in an empty Android Studio project with just a data binding enabled. So we'll be implementing the flows in this project, in this empty project. So flows is nothing but basically a coroutine which can emit multiple values over a period of time. So this is the basic definition of flows. So let's see how we can implement that. So here is a basic hello world layout, and what we are going to do this, I am just keeping it as a 0 and I'll just increase the size of the text to, let's say, 30 sp. Okay, so we want to continuously keep listening to the incoming data and show it to the user. To simulate that, what we'll do, we'll just launch the screen and the data will be the integer data will be incoming from will be stimulating the data is incoming from the server, and we are going to show that. In case of 0, we will be go from 1 to 3, 1 to 10. So this, and as the data becomes available, our UI will automatically refresh to in order to show the latest data. So this is what we are going to achieve. I have already given it a id as a value. So, and for implementing the flows, we can actually launch a coroutine here itself and start the flow here itself and collect it here itself. But I just wanted to show you the recommended approach. So let's create a view model. For that, I right click on this one, new Kotlin class. I'll name it as main view model. So basically, generally you register your flow in your view model. We'll extend it from a view model, and here we are gonna declare a flow, and we'll observe the flow from our main activity. It might be activity or might be a fragment. So this is the recommended approach that I am going to show you here. First one, we'll create a flow. Let's make it as a my flow, and for launching the flow we get a some block called as a flow. So this is a block of code block, and this is a flow. So it asks for which type of data that you want to emit from this flow. So we are going to emit the integer values, so that's why I'll write an int here. In the block of code we are actually will be emitting the values. So we want to emit the values from 0 to 10. So I'll just first make the emission for the 0. Okay, and we have the function at the emit. When we write the emit, this flow will emit the value to the whatever we have specified here. And I'll just declare one variable here. Let's say value equal to 0, and let's do one thing. I'll emit this value. Okay, so now I'll make a loop here. While value is less than 10, then it will emit the values, and before emitting I'll just increase the value plus plus, and it will emit. But I just want to simulate a network call. So network call might have some delay whenever processing the data, when we are receiving the data. So I'll just add a delay function here. We'll make a delay of 1 second. So after each 1 second we'll be receiving the new integer, that is a new data from our server. This is just a simulation for that. If you notice here, delay is actually a suspend function, but we are able to call it from here and it doesn't complain us. Why? Because this flow is a block is actually a coroutine. So this is a block where you can easily you can call your suspend function without any hesitation. So that's why delay is a suspend function and not complaining anything for that. So and here you can just alt enter and remove this explicit type because it has already inferred the type from this emit and from this value. So this is how we'll start imaging our flow. This is how we set up our flow. So now our flow is set up. Now I go to main activity. I want to observe this flow. So now how can we observe this flow? We first need to create an instance for the view model. So I'll first do that. Val view model colon main view model by view models, and here I'll write main view model. That's how we can create a view model instance. Now we are able to access the values in the view model. Now view model dot my flow dot flow has a one function to collect data. We have that the flow there is actually emitting the values and we are collecting here. So we have one function named as collect, gives us a block of code and we get a value here. And if you hover on this one, you will notice that this is the integer value because the flow which we are going to observe is actually emitting a integer value. That's why we get an that integer value we are able to get here. Still our collect function is complaining. Why it is complaining? Because it is a suspend function and it needs to be called from a coroutine. So that's why we'll launch a coroutine here, lifecycle scope dot launch, and we can put it inside this. So this might work, but we need to do some additional here, that is repeat on life cycle. So what is repeat on life cycle? We'll be launching this block itself. Let me write it first and then I'll explain. So this is repeat on life cycle and I am putting this in the this flow collection logic in this block. So what is this repeat on life cycle? Actually we wanted to collect the values from the flow only when our app is in a foreground. If our app has state at the started, then only we want to start the emission. And when our application though is not running, is not in a foreground, it has some state like a stop or pause, then we don't want to collect the values. And actually flow is a there are two types of flows. First one is hot and second one is a cold. So what I mean by hot and cold, so basically the normal flow is a cold flow. Whatever we have declared here, this flow is a cold flow. So cold flow means unless it has some collectors, it won't emit the data. So let me first write here a log statement. We'll make some log as a track flow. Okay, and whenever some emission will happen, this log statement will be logged emitted $value. So this flow is emitting different values and it has a collector here. We are defined the collector here and it is collecting the values. So but that flow will only emit the values when it has some collectors. If it don't have any collectors, then it won't emit the values. This is some type of lazy behavior. Unless it has any collectors, it won't emit the values. If there is no activity running in the foreground, then we don't need to collect the data, and that's we don't want to run this code. That's why this repeat on lifecycle is important. And now inside this, what I am going to do, I am just setting this value binding dot value to the text view, text equal to, I'll just assign this value. Okay, so it is giving an error because it's an integer value, so I'll just write toString here. Fine. Now everything is set up and we'll just launch our application and see what happens. Yes, now application array, let me open the logcat here, and here you can see emitted 1 2 3. We are able to see the emission, and here it is getting collected and it is getting reflected on the UI. So this is how the flow performs. So here one by one emission is happening and one by one collection is happening. So there were 10 values and we have set up the condition here. So when the value becomes 11, it will go out of the loop. So that's how the flow works. That here emissions are happening after a delay of 1 second. So we are stimulating that data. Your server is responding with some piece of data, some integers, and our flow is here observing there. We are collecting it, the data. We are continuously collecting it till the server is uh, giving us the data, and we are just setting that to the text view, and that's why the text views are running from 0 to 10. So the next question is, why to use flows if there are some alternatives? Flow has some different advantages of using them. So let me close this application and minimize. So this function is collect is one of the terminal function which can collect the flow values in the flow, but we can also process the data before it getting collected. So there are different functions for the flow, like dot filter. If we have some incoming values and we want to filter those values, then we can do that with this filter. Now it is asking for some condition which should fit, and it will like some condition. If the incoming data fits in that condition, then only it will forward the data the collect function. So that's condition it is now asking here. So let's say if I just wanted to send a even numbers. So I'll just write a integer mod 2 equals 0. If that number is divisible by 2, if the division comes as a 0, remainder comes as a 0, then only that digit will be forwarded to here. So we'll get only even numbers here. So let's run our application and check that. So you'll be able to see 0 item 1 is skipped, 2, and then 3 is skipped, all directly 4 came here, 6 and 8 and 10 will come here. So the only the even numbers are getting displayed here because of this condition. And so this filter function is filtering the other values, so other values are not reaching this collect function. So another function I want to show you is a map. So as its name suggests, it maps some value to some object. So what does mean? Let's say I have a incoming flow, so I have a incoming integers that are all now even. So I just want to spare those values before coming those values to here collect here. I just want to make a spare of them. So what I'll just write it into it, and let's observe what will happen in that case. Now we're getting a square of 2, square of 4, square of 6, square of 8, and you will get every square of every number. Now it's 100 square of 10. Because how it is happening, this is because of happening of maps. First, this is the incoming stream, so all the digits are coming here. So this filter function has a condition to filter out and to pass forward only the even number. So it is passing forward only the even numbers, and now this map is doing some processing. It is making a square of those numbers, and then it is going to collect, and the collect is setting the value finally in our text view, and now we are able to see the result of all of these operations. So these are two important functions here. Except those functions, there are some other functions as well, like on start. So as its name suggests, on start will triggered when the flow started. So I'll just write a log statement here. I'll just pick the log from here itself. I'll just comment out this for now. Yeah, no, fine. So here I'll just write on start. No, I'll write flow started. Okay. So there is similar function like on completion. Whenever, as its name suggests, whenever the flow is completed, it will be triggered. I'll just write flow completed. And again, another function I wanted to show you, that is for each. for each on each, sorry, on each. So this on each function, as this name suggests, it will be triggered on each collection, on each emission. Whenever the new emission comes and it comes here, gets collected, so it will be called before passing it to the collection. So this block will be triggered on each and every collection. So we will just write collected dollar, sorry, collected dollar it. Yes. Now we'll launch our application. Our primarily we'll see in a locket. Let me clear the locket and just wanted to show you. Now flow started has been triggered. Here it is collected 0, collected 1, and collected 2, collected 3. So for every emission, this on each block is getting fired, and this on start block get fired at the first emission when the flow started, and after all of the emissions are completed, this on completion block is triggered and it is showing as a flow completed. So whenever we want to do some perform some operation just before starting of the flow, then we can put it in the on start block so that this will be triggered. And this on completion, if we want to free up some resources after our complete task is done, then we can write that all the code here in the on completion. So this is a place where we can do that. Now again, I wanted to show one thing practically. As I have already said, this flow is a cold flow. So unless it has any receivers, it won't emit any value. So let's do that. Try doing that practically. I'll keep all these functions and I'll just comment out this collect function. So there are no collectors for this flow now, but the flow has a log statement. Whenever it will emit the value, this statement will be triggered. Now let me clear the logcat and launch the application. It doesn't have any characters for as of now. So you can see here there is no log statement here and there is no value change here. Okay, the value change we have already commented, but we have already removed the collect function here. That is, that flow, that active flow doesn't have any collectors. So if it doesn't have any collectors, it don't want to emit any value to save up the resources. So this is the some advantage of the cold flow. This is how you can actually practically try it. Again, one thing I wanted to show you about the hot and cold flow, difference between the hot and cold. So let's implement it practically. There can be multiple characters to single flow. So I am just uncommitting again and I'm removing all those things. And instead of showing it here, I am just putting in the log statement. Okay, what was it? Flow, sorry, track flow. Okay, and here I'll write collected dollar value. Okay, and I'll just copy this one. So this is the collector 1 and this is the collector 2. I'll just write track flow 1, no, not here, collector 1, and I'll write like this, and I'll name it as a collector 2, so that we should be able to differentiate on the logs. And I'll just remove this log statement from the emission so that we should not get confused with that. So these are two different collectors for observing the same flow, collecting the same emissions. Right? This is also my flow and this is also my flow. There can be these things. And if we try running our application, then see if there is any difference in those. No difference. You can see both are receiving the value simultaneously. 0 0 1 1 2 2 character 1 and 2 are receiving the values simultaneously. Okay, that's fine. I clear the locket now, and stop the application. I do one thing here. I'll delay here by 3 seconds, 3000 milliseconds. So what will happen doing this? This first collector will start collecting as soon as I mean this will start collecting from the beginning, and this collector code is executed, but due to this delay function it will stay here for the 3 seconds, and after the 3 seconds it will start collecting the emissions. So let's see if there is a difference happens in that, or what happens in the logcat. Okay, collector 1 has received 0, 1, 2. Now after the 3 emission, that is 3 seconds, collector 2 also get activated. But if you observe this one, collector 2 also started collecting the emissions from the 0. That is the collector 2 has received 0, 1, 2. Even if the collector 1 has already received 0, 1, 2, still the collector 2 is able to get the lost data, previous data. Like let's compare it with the some movie theater. Let's you went to the movie theater, the show is of 12 p.m, let's say, and you reached on time, but I reached later. I reached in the second half of the movie, after the interval. So whatever the movie that was in the first half of the first half, that is the first interval, I didn't get that. I already lost that because I was not present. I was not collecting that. But you were collecting that. You were able to get that. But I was not able to get that. I will only get the movie since the moment I started collecting it. I started going to the movie theater. So that's the, and that happens with the hot flow. And as this is cold flow, in the case of cold flow, it's just like we can refer to this as OTT. We both can watch the same movie in our different, according to on our devices, according to our convenience. So we won't lose any data. So that is happening with both of the collectors here. So first collector is taking the has started the collecting the things, and it started 0, collecting 0, 1, 2 up to 10. But after 3 seconds, when collector 2 joined, collector 2 won't be missing anything. So collector, when collector 2 comes and says emitter please give me the values, so emitter will give the values from the starting. So that is one of the difference between hot and cold. So that is for this tutorial. In the next videos we will be seeing about state flows, shared flows, and many other things. So make sure you attend that. That will be more interesting. And I hope you have now fair idea about what the flows, how we can uh, emit them, how we can collect them in a recommended way from the view model. Make sure to make the practice of that at least once, so that you get a clear understanding of that. If you still have some doubts, you can put your questions in the comment box below. I will try my best to answer those. If you like this video, then please click on like, share with your friends, and don't forget to subscribe to this channel, so that you will be notified whenever a new such amazing video is published. We will meet in the next tutorial with some another interesting topic. Till then, goodbye. Happy coding.